Hey guys, how's everyone? Okay, I am hoping that everyone is doing good. It's been a long time since the last class. Actually, I was having plenty of work in the office and still having a lot of work. So yeah, even for API sessions, I have just kept 2 or 3 sessions per week. So we will be not having many classes like for the next 1 month. But yeah, we'll be covering the syllabus on time. Don't worry. Okay. I'm hoping that everyone is good, right? Okay, guys. So
Yes, sir. Yes.
okay, that's super cool. Okay, guys, and one more thing, and this will be the last theoretical session of manual testing. We will keep a project for pending. Okay, we will do that later. Might be covered by Rajat or me. Might be covered by Rajat most probably. Okay, so yeah, we will be doing a project over Jira. We will be looking into how to create test cases, how to create test plan, reports, and everything on Jira. Okay, that will give you a real time project feel. Okay, so we will be doing this last topic, and we are also planning for mock interviews of Java. But we were both Rajat and me were not having time to discuss it with the students. Okay, anyways, so let's start with today's lecture. Okay, guys, I want a thumbs up if everyone is able to view the screen. Okay, that's cool. Okay, guys, so I won't take this lecture too long. We have like one, two, three, four, and five topics. Okay, so I just want to discuss the bug life cycle once again. I have already covered this topic 2 times, and I am covering it for the third time because that's a very important topic. Okay, so again, I will I will only ask from any one of you. I will not ask from everyone. Okay, Sujit, what's bug life cycle? Sujit, you there?
Hello, sir.
Yeah, Sujit, go ahead. What's bug life cycle?
The bug life cycle basically defines the different stages or defects, basically, different stages of a bug that goes through from identification to closure of the software development process.
Okay, Sujit, first thing, it's from the creation to end of closing of a bug, not software development process. Okay, I don't know why you guys are still lacking in the definitions. I have told you many times, go through the notes, go through the notes. I don't know why this is happening. Okay, anyways, guys, give me a thumbs up if this is clearly visible. Okay, cool, guys. See, that's a very simple definition. I am explaining you it in very simple definition. The journey of a bug from its identification to its closure. Simple. You need to add nothing. Nothing. This is very simple. Journey of a bug from its identification to its closure. Okay. Is this good for everyone? Is this understood by everyone? Okay, guys, cool. And the next is stages in the life cycle. The first stage is the new stage when the bug is identified and reported. Okay, when the bug is identified and reported, then the stage changes to assigned. Okay, it will be allocated to a developer for resolution. Okay, it will be assigned to a developer for resolving. When developer starts working on this bug, the developer move its status to open. Okay, open. The open status means developer is working on the bug. All right, and then once it got fixed, it got fixed. The developer move its status to fix. Okay, and then when it got fixed, it is assigned to the tester for retesting it. The status is retesting. Okay, the status is retesting. Okay, and if the issue still persists, the issue is not resolved even after the developer fixing it, it will be reopened. Okay, it will be reopened. And if it if the issue is good, it's working as expected, the issue is not occurring again and again. Okay, then the bug is verified. Okay, verified, and later on it's closed at the end of a sprint. Okay, deferred. Okay, postponed for future releases. Okay, there might be, I already told you this, that there might be chances that the bug is not very impactful and we have other of things to do too. Okay, so that will be the deferred. Okay, and duplicate. Duplicate means this is reported multiple times. You can see it twice or thrice or more than that. Okay, so this is the bug life cycle. Is this clear, guys? Give me a thumbs up. I have explained it 3 times in 3 different lectures. I'm hoping that this is clear now. Okay, guys, that's cool. So that's clear to everyone. All right, guys. So moving on to the next topic. The next topic is test closer. And guys, before we discuss test closer, I want to ask every one of you uh, when we can stop testing, when we can stop the testing.
Sir, when the main requirement is completed, when the tester and developer are all are satisfied with the software, then we can close the testing.
Okay. Anyone else?
When the test is verified and validated.
Okay.
When the software quality meets the requirement, then we can close the test.
Okay. See, when all the majority bugs are fixed, when all the majority bugs, if where when I'm saying majority, that means high severity and high priority bugs. Okay, when all the high priority and high severity bugs are closed and all the requirements are met, then we can close the testing. Okay, then we can stop the testing. Is this understood by everyone? Okay, guys, that's good. Okay, so what's test closure? The formal completion of the testing process, ensuring all objectives are met. Okay, okay. What are the activities in the test closure? We need to ensure that all the planned test cases are executed. Okay, all the test results and defects are reported. We need to analyze that there are no high severity and high priority bugs. Okay, and open issues. Okay, test summary report is prepared. Okay, and archive text test artifacts are just the documents related to testing. Okay, when to stop testing? Okay, the first thing we need is to check the project timelines are met. Okay, coverage. All test cases are executed with sufficient coverage, quality goals, acceptable defect rates. That means no high priority and high severity bugs. Okay, a risk analysis is again the same, no high severity bugs. Budget constraints, resources are exhausted. Okay, okay, guys, is that understood by everyone? Okay, guys, software testing metrics. Software testing metrics are nothing, but these are just quantitative measures. You know what's quantitative? That can be count. Quantitative measures to track the progress and effectiveness of testing activities. Is this clear, guys? Okay, and these are process metrics. Okay, like test case preparation rate. How many test case per module is prepared? Okay, that's one of the case. And product metrics, density. How many defects are found per module? Okay, how many defects are found per module? Project metrics, test execution rate. How many tests are executed? Okay, how many tests are executed? Okay, guys, just left with two topics. I will complete this very soon. Then we will talk a bit. Okay, then we will talk a bit about things, few things. Okay, guys, many times this question is asked, what are your day to day activities as a QA? Okay, what are your day to day activities as a QA? So I just want this question to get covered. Okay, so see, these are the activities that are involved in QA testing, test planning. Okay, what does test planning include? Defining the scope, resources, and timeline. Designing tests, that means creating test cases and scenarios. Okay, and then we have test execution. Test execution is nothing, it's just performing the test cases and identifying the defects and reporting them. Okay, and defect reporting is same as we, uh, we do report the ticket on Jira, raising a bug, these kind of things. Okay, and then we have test closer, which we discussed earlier. Okay, which we discussed. Okay, so these are summarizing and documenting the results. Okay, is this clear, guys? Give me a thumbs up if this is clear. These are very easy and theoretical definition topics, nothing else. Okay, guys. So the last topic of this class is principles of software testing. Okay, guys. So these are key principles of software testing that you have to always keep in your mind while testing. Okay. So these are the key points, guys. Just listen carefully. Okay. The first is testing shows presence of defects. Okay. What does that mean? Testing reduces defects. Okay. We will test, we will find the bugs. Okay. But that does not means that closing bugs, they keep on testing and closing bugs will remove them. Okay, will remove them from a software. Okay, will remove them completely. When I say remove them, then I mean remove them completely. You got it? So testing reduces defects, but it does not prove their absence. Okay, exhaustive testing is impossible. What does exhausting testing means? This means achieving the 100% bug free software, which is not possible. Okay, every time a new tester will come on the project, will test it on its own way, he or she is definitely going to find a new way because he is testing it from his point of view. Every human has a different point of view. They got this, guys. Give me a thumbs up, guys, if you got this. Okay, guys, that's cool. Okay, defect clustering. Defect clustering means most defects are found in small number of modules. When I say small number of modules are pointing to the largest module. If I say that's an e-commerce application, where you will find the most of the bugs. You will find most of the bug in checkout processes. Am I right? You are going to find the most of the bugs in checkout processes because most complicated logic is implemented in that section. Is that right, guys? Give me a thumbs up, guys, if you understood. Okay, testing is context dependent. What does I mean when I say context dependence? That your approach will every time vary, will be every time different when you will be testing a different application. For example, today you are testing a banking application, you will have a different approach. Tomorrow you are testing a learning management system or a e-commerce app, then your approach is going to differ. Give me a thumbs up if you agree. Okay, the last and final point is absence of errors policy. What does that mean? Absence of error policy means even if your bug is 100% free, then it's not of use until it's not meeting the requirement, right? Your software should always meet the user requirement first, and then it should be having less bug or bug free. Okay, you got that, guys? Okay, guys. So that's it for today's class and the complete theory. We will have a project on Jira where we will be discussing agile and some practical scenarios. Okay, so we will be doing that. Don't worry. But before we just dive into that, I just want you guys to cover up API. Okay, so I am holding these classes. We'll be shifting towards API from tomorrow. Okay, okay, guys. So that's it. Okay, now I want to talk with you guys. Okay, guys. So we are done for the class. If anyone is having any doubt or if anyone wants to ask anything, can go ahead. And if no one is willing to ask anything or have any doubts, we can wind up.
Sir, can you tell me which domain should we have knowledge about during testing? Means e-commerce app, banking, and more. How much means?
Sujit, see, I will be sharing one of my LinkedIn post with you. Okay, go through it. You will understand the things. Okay.
As a fresher, how much we should have this knowledge of domain?
As a fresher, you should just have the knowledge of it. Okay.
Okay. Okay, sir.
Anyone else is willing to ask anything? Okay, so if no one is willing to ask anything, I guess we can wind up, right? Okay,
Okay, sir.
guys. Okay, guys. So bye bye. See you tomorrow in the Selenium class. Okay. Okay. Whosoever
Bye,
is
sir.
enrolled.